Okay, hi, hello, okay. Um, Welcome to my final video for the traffic volume predictor project. In this walkthrough, I'm gonna show how I analyze the data set, the traffic data set that was provided, how I use that to build prediction models and create interfaces for users to both predict and update traffic volume data. So this is the Jupyter Lab notebook um, file that was given to us, where like we need to use the markdown cells to like just create our code and upload the data, and our data sets and everything. So the first thing I did was obviously upload the data set that was given to us, the traffic data set, so I can use this information to analyze the features. So the data set contained over nearly 44,000 hourly traffic records, and I engineered useful features like the day of the week and combined the year, month, day, and hour to create a proper date time. This made it possible to group traffic by the time and build models. So I just put in a standard code um, to upload the file that was given to us. I downloaded it, and then yeah, I was able to upload it, and I was given the information. So we needed the days of the week because traffic patterns are very different on weekends versus weekdays, and the hour helps us model the daily traffic cycles. So this was my literature review. I'll get to that. I mean, I don't think I need to cover that through here, but this is the code I used to create the line plots or the pair plots showing vehicle volumes by hour/day, and these were the trends that were shown, that were given to me from the code. And yeah, it just helped me give me a broader view of how like this just helped confirm how like time variables, especially the hour and weekdays, were good predictors of traffic volume. So this was very helpful. And then I used this code to give me the junction performances for junction 1, 2, and 3, which were on the traffic data sets. I did come across an error that I wasn't too sure of, but I think this wasn't an error. This was just like a warning. But yeah, so I wasn't too sure what that meant. I tried like toggling around it, but this like was inevitable when I put in my code and tried fixing it. But it still gave me the junction performances. So we tested two models, a simple linear regression and a polynomial regression for each junction, using the hour and the day of the week as inputs. So this was the code that I used to show the model training, and the results of this gave me, I had to put in the junction from the traffic data set, the hour of the day from the traffic data set, the enter the day of the week, and like all the information I was given, and then it gave me the predicted travel volume at junction 2 from per hour for the hour, the day of the week, and the predicted vehicles. And the polynomial models performed better, especially for junction 1, because I picked the best model for each junction using RMSE and R2 values. And then this was the terminal-based prediction tool. This let like anyone who's trying to, or yeah, this let me input a junction number, hour of the day, and day of the week, and returns a predicted travel volume with an uncertainty estimate based on our MSE, which is this. And this, we just needed to put in the um the details, the junction number, the hour of the day, the day of the week, and it gave us the predicted traffic volume at junction 2. Um, and this was the polynomial model that performed better for the junctions, for junction 1 specifically, but this was just the code for the polynomial model. And then this was the code to update the tool. Well, first of all, before I move on from that, this this tool just made it more practical for users or anyone who's trying to use the code, which is me. So it just made it more practical for me to check traffic forecast and planning, and like the analysis of the traffic data in general. And then this was the code for the updating the tool. I created a second interface that allowed me to add new data once a new traffic observation was added, and the model for the junction is retrained automatically. So yeah, this is what I did. Train the model, and yeah, this was the output. So I had to put in the year on the traffic data set that was given to us, which let me just bring up real quick. So I chose a random year. I chose 2016, May 26th, which is my birthday. But yeah, that's just the date I decided to choose. And there were multiple ones. I chose the junction 1, and the vehicle count was 48. And the new observation, the code was able to analyze the traffic observation and add it, and it gave us a new RMSE of 19.83. And yeah, that's about it. This was the traffic prediction tool, and the yeah, I hope this project like very much showed how machine learning and time-based patterns can help like tackle real urban challenges, because people that are working in this like trying to like navigate traffic data can very much use this type of tool to help them assess how they can regulate like traffic details, and like whatever they use this for. And yeah, this is what I did, and I feel like I met all the requirements. And yeah, before I end this though, I'm gonna open the I have it written down. It was the interface. Okay, I don't think I have the file saved, but I'll upload that, and I have my interim report here, which showed like what I did and like how I loaded the traffic data file, and what I needed to do and the testing for it. And yeah, I will submit that alongside my literature review for the report. And yeah, this is my project.